and this is a video for CS360. And in this video, we will cover the conversion between from NFAs to regular expressions. So recall that NFAs, DFAs, and regular expressions are all equivalent in terms of their expressive power. They all give rise to the regular languages. And we saw the conversions in the notes and also discussed them briefly in the previous video. So of the three conversions, arguably the most challenging is how to convert from from NFAs to regular expressions. So to understand why regular expressions are as powerful as NFAs. And of course, we also know that NFAs and DFAs are equivalent in power. There was a separate argument for that in the notes. So this means that here, the difficult direction that we're going to try to do is to explain why it is that regular expressions can do everything that an NFA or a DFA can do. So why is it that whenever you have an NFA, you have a regular expression? So so the way we proved it in the notes is that we go through this intermediate stage of regular expression NFAs, R NFAs. So maybe the best way to do this is to just give an example. So let's go through an example of a DFA that we will convert to a regular expression. And let's have this be the DFA for the language. So our alphabet is going to be 0, 1, and we will take all the strings over 0, 1, such that the number of ones in the string is divisible by 3. So it's equivalent to 0 mod 3. So this is going to be our language. And so we can write a DFA for this fairly easily. The DFA just has to count the number of ones modulo 3. So if we have our start state here, let's call it Q0. And then when we see a 1, we will move to Q1. When we see a 2, we will move to Q2. When we see a 1 rather. Oops. Of course, when we see a 1, we move to Q2. And then when we see another 1, we move back to Q0. And when we see a 0, we stay in the same spot. Okay. And finally, the accept state is going to be this initial state because we want to accept a string if the number of ones is 0 mod 3. So here you can see this DFA is going to be in state Q0 if so far it saw number of ones that's equivalent to 0 mod 3. It's going to be in state Q1 if it saw a number of ones that's equivalent to 1 mod 3, and it's going to be in state Q2 if it saw a number of ones that's equivalent to 2 mod 3. So, okay, so this is our DFA. So let's now convert this to a regular expression. And the way this is going to work, well, we're actually going to, the way we had it in the notes, we were going to want the initial state to not have any loops, any self loops, and also we want the accept only one. We want only one accept state, and we want it to also not have any loops, and we want it to not be the initial state. So this is already not going to happen here. So our first step will be to write an NFA that has these conditions, so that kind of fixes this issue of having a loop on the initial state and having the accept state not be its own separate thing. So so we will fix it as follows. We will add a new initial state. Okay, so let's call this, I don't know, P0 or something. Okay, so we have a new initial state. And the new initial state will have an epsilon transition to Q0. Actually, let's not make this an accept state. We'll have an epsilon. We can move for free from P0 to Q0, and we can also move for free from Q0 to another new state, which we'll call P1, and that will be our only accept state. Okay, so P1 is going to be the only accept state here. We'll move for free from Q0 to P1, and then otherwise everything is the same. So we'll have our Q1 state here, and Q2. Okay, and we'll have these loops with zeros, just like before. So we have the same, well, we had the DFA before. Now we make this an NFA with two new states, one for that's a new initial state, one that's a new accept state. And we'll have epsilon transitions that tell us that we can go from the new initial state to the old initial state for free without reading anything. And we can go from any previous accept states, and whichever of these were accept states, we can put epsilon transitions from those to this new final accept state. And there's only going to be one accept state in the end. And once you reach the accept state, you can never leave it. There's no outgoing arcs from this accept state, and also there's no incoming arcs to the initial state. You never return to it. So okay, so that we can achieve just by kind of trivially adding epsilon transitions. And so once we've done this, then our next goal will be to eliminate all the other states. So we're going to want to delete these three states, the Q0 through Q2. We want to delete those, and we want to keep, so like we want to delete these three states here, and we want to keep the state P1 and P0, P0 and P1. And so all we need to know how to do basically is to understand how to delete one state from such an NFA. And in general, when we delete a state from such an NFA, we don't get an NFA, we get what's called an RNFA. This is sort of an NFA where the arcs are labeled by regular expressions. So let's just do an example here. Let's delete, it's a relatively simple state to delete. So let's delete Q2. So let's say we want to delete Q2 here. So what we're going to do when we delete Q2 is, so first of all, let's just redraw everything so that we can kind of write things down as we figure them out. So this is P1 here. Then we have Q1 over here. Okay, so we want to delete Q2. Q2 is over here. So basically the way this works is we ask, when would we have ever gone through Q2? So we never, when we accept a string, when this NFA accepts a string, it never reaches Q2 and stays there because Q2 is not an accept state. So it goes intermediate, a string might in an intermediate stage go through Q2, but it won't stay in Q2. So which strings go through Q2? What does it mean to go through Q2? What are all the ways of going through Q2? And so what are all the ways of entering from one state and leaving to another? And you can see that here there's only actually one way to enter Q2. You can only enter Q2 from Q1. And there's only one way to leave Q2. Okay, we're ignoring this loop here. Only one way to leave Q2 and go to a different state out, and that's to go to Q0. So there's only one way to go through Q2, and that's to go from Q1 to Q0. So we will add a new arc here that goes from Q1 to Q0 that's going to represent having gone through Q2. Now, when we go through Q2, what do we need to read in order to take this path? So if we want to take this path from Q1 over here, we want to read a 1 basically, go to Q2, and then go to Q0. So yes, we need to read a 1 here in order to get to Q2, and we need to read a 1 in order to leave. But we can also read any number of zeros along the way. So really, we can be reading 1, any number of zeros, and then another 1. And that allows us to get from Q1 to Q0, passing through Q2. So in other words, the way to go through Q2 and is the only way to go through to Q2 at all really is to go from Q1 to Q0 while reading a string that matches to 1, 0, star 1. Okay, so that will be the label on this arc now. So now we've deleted Q2, we've placed this regular expression here in this new arc in our RNFA, so that this object is now going to be called RNFA because an NFA labeled with regular expressions. That's what the R stands for. And you know, we can take an arc. When we take an arc on the RNFA, that means that we must read some sequence of symbols that matches to that regular expression. So we can go through. We can go through this arc over here while reading 1, 1. Or we can go through this arc over here while reading 1, 0, 1, or while reading 1, 0, 0, 1. So, you know, and for any of these things, we can take this arc here. But we cannot take this arc if we are trying to read 0. If we read 0, well, I suppose we would have to loop. Or, you know, we can also not take this arc if we want to read 1, 1, 1. We would have to only read 1, 1, end up here, and then read another 1, and I guess come back over here. Okay, so you have to read something that matches the regular expression if you want to take an arc labeled by that regular expression. Okay, and you have a choice of which string that matches the regular expression you would like to read. Okay, so that was just one example of eliminating Q2 from this NFA over there. So we keep going. So now we have 2 states left to eliminate. We want to eliminate Q0 and we want to eliminate Q1. So let's do a more complicated example and let's try to eliminate Q0 first before Q1. Okay, so that's the more difficult task because it has more incoming and outgoing arcs. Okay, so what I'm going to do is I'm going to erase this over here. You have it in video anyway. Okay, so that I can draw over here on the left. Okay, so let's, as before, so we will have, okay, so we have our states P0, okay, which is, we know is a start state, and we have P1. I'll draw it over here. Okay, and we are going to delete Q0, so we will have Q1. Okay, and we know that we have a loop here. That's 0. Okay, so what are all the ways of going through Q0 over here, of going through Q0? So note that there's actually 2 ways to enter Q0. We can enter Q0 from P0 or from Q1. And there's 2 ways to leave. We can leave Q0 either through to P1 or to Q1. Okay, so the number of ways of entering through one of these 2 entrances and leaving through one of the 2 exits, well, there's 2 times 2 ways of matching them. So there's 4 ways. So we actually are going to need to write to introduce 4 arcs that, of course, replace Q0, delete Q0, but add in 4 new arcs. Okay, so the 4 new arcs are going to be, 1 corresponds to entering from P0, leaving to P1. So that's going to correspond to this arc over here. 1 is going to be entering from P0, leaving through Q1. So that's going to be an arc like this. Okay, and then again, we will have entering from Q1, leaving through P1, to P1. So that will be an arc like this. And finally, there's going to be entering from Q1 and leaving to Q1. So that's going to be an arc like this. And yes, we will have 2 loops on Q1, and we will see how to deal with that. Okay, so we will merge the two loops afterwards. Okay, so we have here 4 unlabeled arcs that we need to now label, and we will label them with regular expressions. Okay, so let's take them in order. So the first one we dealt with was coming in from P0 and leaving to P1. Now, okay, so what are all the ways of doing that? So we have to read epsilon in order to get to Q0, and read epsilon in order to leave, but actually we can read any number of zeros along the way. Okay, so epsilon, any number of zeros and then epsilon, that string is just the regular expression 0 star. So we will label this thing by 0 star. Okay, so we have an arc from P0 to P1 labeled by 0 star. And next, we consider entering from P0 and then leaving through to Q1. So we have to read epsilon to get here, any number of zeros, and then a 1. So this is going to be 0 star 1. Okay, and then next, entering from Q1, leaving through P1. So this we have to read a string that matches 1, 0 star 1, then any number of zeros, and then epsilon. So this is going to be 1, 0 star 1, and then any number of zeros. So that's another 0 star. Okay, so we have this label over here. And then finally, if we want to enter from Q1 and leave to Q1, we have to read a string that matches 1, 0 star 1, and then any number of zeros, and then a 1. So we get 1, 0 star 1. Any number of zeros means 0 star, and then finally another 1. Okay, so we get this RNFA on the left. And now we had 2 loops on Q1. So we have like a double arc here, 2 arcs that go from the same state to the same state. When that happens, we can merge them by taking a union. So essentially, the meaning of having these 2 arcs is that you are allowed to take a loop on Q1 while reading 0, but you're also allowed to take a loop on Q1 while reading a string that matches this regular expression here. So because you're allowed either, we can represent that with a single regular expression, which is the union of both. So we'll put a union 0, and we can then delete this arc, and we get the same, an RNFA that behaves exactly the same. Okay, so we've simplified by deleting the duplicate arcs, and we are back to just a plain old RNFA. Okay, so and then we've eliminated Q0 here. And as you can see, there's only one state left that's not the initial state or the one accept state. There's one state left to delete, which is Q1. So let's finish the construction by deleting Q1. I'll erase the RNFA on the right. Okay, so let's do this. So we want, we have P0. Okay, we have P1. Okay, we have this arc that we already know is going to be there that's labeled by 0 star. Okay, and then we are interested in deleting Q1. So now the only way to enter and leave Q1 is to enter from P0 and leave to P1. So to do that, we're going to get a new arc from P0 to P1. And the new arc is going to be labeled by, well, in order to take this arc, we have to pass through Q1. So we have to read 0 star 1, or a string that matches 0 star 1, then read any number of strings that match this, and then read this a string that matches this regular expression over here, 1 0 star or 1 0 star. So putting that all together, we get the regular expression 0 star 1, and then in bracket 1 0 star 1 0 star 1 union 0, all star. So we can take the loop there any number of times. That's why there's a big star on the outside. And then 1 0 star 1 0 star. Okay, so we get this big mess. And finally, we now have duplicate arcs. So we have 2 arcs. So this is not really a valid RNFA. We want to merge these arcs in order to get just a plain old RNFA. So let's merge these arcs. So let's put a union 0 star over here. So we merge by adding a union. And after we do that, we are free to delete this arc. Okay. And finally, we have this. So we have this RNFA now that just looks like this. It looks like P0, some regular expression R, and then P1. Okay. And once we get an RNFA of this form, then you can see that the only strings it accepts are the strings that match this regular expression. In fact, exactly the strings it accepts are the strings that match this regular expression R, right? Because you can only accept if you reach P1 and you've read everything there is to read. So in order to accept in an NFA or an RNFA, you have to reach an accept state and you have to have read all the symbols there is to read. So here you need to basically exactly match this regular expression R in order to go from P0 to P1 and have read everything. So it's just very simple. The strings that are accepted by this RNFA are the strings that match the regular expression R. And so therefore a regular expression for our language A, for the original language A, should be this mess here. So it should be this 0, it's this string here is 0 star 1, and then bracket 1 0 star 1 0 star 1 union 0 all star 1 0 star 1 0 star union 0 star. Fine. This is a big mess. This is not the cleanest regular expression for the language A. You can come up with better regular expressions. Let's see if we can convince ourselves that this is right. Okay, that this is accurate. So we want the number of ones to be a multiple of 3. So first of all, no ones, 0 ones, that's a multiple of 3. So that's why there's a union 0 star here. So a string that's all zeros will match this regular expression. Okay, so because of this union 0 star. Okay, but any other string will have at least 3 ones, and here you can see that the string will have 1 1 from here, 1 1 over here, and 1 1 over here, and you can have any number of zeros in between the ones. Okay, and then over here in the middle there's this block where first of all you can put any number of zeros, because you can always expand this block by taking the 0 part of this union any number of times. So you have a star here. You can take any number of such blocks that you want. But such a block can match just to the single symbol 0. So you can kind of use this big bracket star thing to put any number of zeros you want. But you can also put any number of blocks of 3 ones of just substrings that have 3 ones with possible zeros in between. So you can put any number of 3 1 substrings that you want with possibly 0 in betweens, or any number of zeros in any order. And so essentially what that means is you just get strings that have the number of ones being a multiple of 3. Okay, so this regular expression is correct. It's a very messy one. We can write down a better regular expression. Regular expression might be something like, let's see, we would want 1 0 star 1 0 0 star 1 0 star. So this is a block of 3 ones. We can take any number of blocks of 3 ones that we want, and we can start it with any number of zeros. So for example, this would be another regular expression, potentially a simpler one that I believe should also match the same language. Yeah, so this is certainly not the simplest regular expression, but it is a valid one, and so this basically sketches the proof of why you can convert any NFA you want into a regular expression for the same language. And the reason this is possible is through this RNFA argument that we go through in the middle. All right.